Hi students, see today I am going to discuss about the surface chemistry. See, so far we discussed here the solid state chemistry, then solution, electrochemistry, chemical kinetics. Up to this is numerical based questions and the theoretical part. In this lesson, the surface chemistry, only the theoretical part. In your standard level, the theoretical part. Here I am going to show the question and just make a note for the answer. I will tell you the key points and the answer, just make a note. We will discuss now the question paper. Hi students, today we are going to discuss about the previous year chapter, that is surface chemistry. The chapter name surface chemistry. The 2015 to 20 question papers. See, in this lesson you have to concentrate in this topic, mainly the types of adsorption. The types of adsorption, know that chemical adsorption, physical adsorption. Then the distinction between the true solution, colloids and the suspension. So these things you have to concentrate. After that, the lyophilic, the lyophobic salt. Lyophilic salt, lyophobic salt, then multimolecular colloids, macromolecular colloids. So the types of colloid. Then the properties of colloid. The colloids are properties like Brownian movement, Tyndall effect. So these things you have to concentrate. And thus the emulsion. The academic year 2021, you don't have the emulsion. Emulsion is a deleted part. So you need not to study this part for the academic year 2021. So you have to concentrate these 4 parts, you will get a more mark. In this lesson, completely theoretical part. So now we will see one by one the question wise. See, look at this question, students. The questions usually like this only. The simple questions are come. Why? The first question is, why are medicines more effective in the colloidal state? See, the medicines are more effective in the colloidal state. Reason is they have a large surface area. So the answer is, it is due to the large surface area and the medicines are easily assimilated in this form. So the answer, key point is, medicine have a large surface area. Then second question, the Brownian movement. The Brownian movement provides the stability to the colloidal salt. Why? Let us give reason why the Brownian movements provide the stability of the colloidal solution. The reason is, see, the Brownian movement has stirring effect which does not permit the colloidal particle to the settle down. See, it does not allow the particles to the settle down. It is responsible for the stability of the colloidal solution. So yeah, the answer key is, a particle does not allow to settle down. That is why they are Brownian movements provide the stability of the colloidal solution. So the key point is, does not allow the particle, does not allow to the settle down in the bottom of the part. Then define associated colloids. What is that? Associated colloids. And see the with example also. Here the associated colloids, usually they like behave like a electrolyte in the aqueous solution. They are in the low concentration but forms colloid in the high concentration. So the definition of associated colloid is, they behave like a electrolyte in aqueous solution in low concentration but form colloids in the high concentration. So this is the definition. Example, soaps and the detergents. Then what are the characteristics of the multimolecular colloids? Here the colloidal particle consists of the aggregate of the small atom or molecule. So this is the characteristic. The colloidal particle consists of aggregates of small atoms or molecule. So the key word is small atoms or molecule. Example, that is As2 arsenic sulfide salt is the example of the multimolecular colloid. Then define Tyndall effect. You were already studied in class 9 itself also. So the Tyndall effect, that is a well known effect. Here the Tyndall effect is when beam of light is passed through a colloidal solution, its path becomes clearly visible due to the skirting of light by the colloidal particle. So, this is called Tyndall effect. I repeat this, a beam of light passed through a colloidal solution, its path is clearly visible due to the skirting of light. So, this is called Tyndall effect. Then, true solution. Next is the very important one. This, see, the true solution does not show Tyndall effect. Why? See, usually the colloidal solution, the first one, the colloidal solution shows the Tyndall effect, but the true solution does not shows the Tyndall effect. Why? The reason is the particle size is very small, that is less than 1 nanometer. So, do not skirting the light. That is why the true solution does not show the Tyndall effect. So, the answer key is true solution does not show Tyndall effect. Why? Reason mean the particle size is very small or too small, less than 1 nanometer. That is why the particle cannot be skirted in the light. That is why the true solution does not show the Tyndall effect. Look at the next question. How does chemisorption vary with temperature? This is the question. Now, the answer is the chemisorption first increase and then increase the temperature. So, because here some activation energy is needed for formation of the covalent bond, but at high temperature bond will break. So, how does the chemisorption vary with temperature means you have to write that's chemisorption first increase and then decrease with increasing temperature because some activation energy is needed for formation of covalent bond, but at high temperature bond will break. So, this is the answer. Then here the key point is increase first in chemisorption first increase and then it decrease with increasing temperature. Then reason and one more reason is because of the activation energy is needed, formation of the covalent bond. This is the key word. Then what happens when a freshly prepared precipitate of ferric hydroxide salt is shaken with a small amount of ferric chloride solution? Then persistent dialysis of a colloidal solution is carried out. What happens when the persistent dialysis of a colloidal solution is carried out? Now, here the answer is what happened when, see, first you have to check two questions are there, that is the subdivision, there are two questions are there. So, answer, first question answer is, the first subdivision, the colloidal solution of the ferric hydroxide salt will be formed because of the peptidization takes place. Here that answer is, keyword is peptidization takes place. The colloidal solution of ferric hydroxide salt will be formed because peptidization takes place. This is carries 1 mark. Then see, look at this question. You can easily answer that is a freshly prepared precipitate of ferric hydroxide salt is shaken with a small amount of ferric chloride solution. So that you can easily tell that the ferric hydroxide salt, the colloidal will be formed because of the peptidization. Just you can write it the peptidization only, the answer key that carries a mark. Then persistent dialysis. What happens when persistent dialysis of a colloidal solution is carried out? Here the answer is the coagulation. Here the persistent dialysis, the coagulation will take place due to the removal of traces of electrolyte which stabilize the colloidal solution. So, I repeat this answer, the coagulation will take place due to the removal of traces of electrolyte which stabilize the colloidal solution. So, the keyword is the coagulation takes place. Then next question is out of starch and the ferric hydroxide salt, out of starch and the ferric hydroxide salt, which is more easily coagulated and why? So, you have to, which one is either starch or ferric hydroxide salt, you have to answer and the reason carries answer. So, this carries half mark and the next the sub part of the reason carries half mark. So out of starch and the ferric hydroxide salt, which is more coagulated? You can easily tell that is ferric hydroxide salt. Reason, this is because of the lyophobic salt. The ferric hydroxide salt is lyophobic salt. Starch is a lyophilic salt. That is why the ferric hydroxide salt easily coagulated because of the lyophobic salt. Then the next is why the adsorption always in the exothermic. Why adsorption always in the exothermic? See, here the reason is the bond formation between the adsorbent and the adsorbate. So energy is released because of the why exothermic means adsorption is always exothermic means the bond formation is between adsorbent and the adsorbate. This is the key point. The bond formation between the adsorbent and the adsorbate. So energy is released. When the energy is released means the reaction will be exothermic in nature. Look at the next question. Give reason for the following observations. The first one is the finely divided substance is more effective as an adsorbent. Then second question is the lyophilic colloids are also called reversible salt. So the first question answer is the finely divided substance is more effective as an adsorbent because the finely divided substance have more surface area. So more surface area means it's a better adsorbent. So the reason is, the key point is the finely divided substance having more surface area, that is why more effective on the adsorbent. So this is the answer. Then the lyophilic colloids. The lyophilic, usually you can tell it there is a greater surface area also. There is the greater surface area, more will be the extent of the adsorption. Then lyophilic colloids are also called the reversible salt. Here the lyophilic salt dispersion medium can be separated from the dispersed phase. So under remixing them we get the lyophilic salt again. So that is why it is a reversible salt. Okay, I will tell you, repeat that. The lyophilic salt, the dispersion medium can be separated from the dispersion phase, that is dispersed phase, and the remixing them. So we get a lyophilic salt again. So that is why it is a reversible salt. Then the this question, 12th question, write one similarity between the physisorption and the chemisorption, or the physical adsorption and the chemical adsorption. See, here both physical adsorption and the chemical adsorption having exothermic in nature. That's one similarities. Both physical and the chemical adsorption having exothermic in nature, and they have both are surface phenomena. Physisorption and the chemisorption is a surface phenomena, that is both increase with the increase in the surface area. So this is the similarities between the physisorption and the chemisorption. I will repeat this. The similarities is they have both as exothermic in nature. Second is both are surface phenomena, that is both increase with increase in the surface area. Then third is write the dispersed phase and the dispersion medium of milk. Write the dispersed phase and the dispersion medium of milk. In milk, there is a liquid is dispersed in liquid. Liquid is dispersed in liquid, that is protein, fat, lactose are dispersed in water. So this is the answer. I will repeat this. In milk, liquid is dispersed in liquid, that is protein, fat, lactose are dispersed in water. Then the 14th question is define the following terms. First, the critical missile concentration, safe selective catalysis, Zeta potential, Kraft temperature. First, the critical missile concentration. The critical missile concentration is the minimum concentration at which missile formation takes place. So this is called CMC, that is critical missile concentration. I will repeat this. The minimum concentration at which missile formation takes place, that is called CMC, or critical missile concentration. Then safe selective catalysis. The safe selective catalysis, that usually this is catalytic reaction in which the catalyst catalyzes the reactants of the specific shape and size is called safe selective catalysis. Simply example, ZSM5, that is convert alcohol to that gasoline. Then usually the homogeneous and the heterogeneous catalysis are deleted for the academic year 2021. Okay. Then the zeta potential. The zeta potential or electrokinetic potential. You can tell it the zeta potential, or sometimes comes with electrokinetic potential. Here, the potential difference between the fixed layer and the diffused layers of colloidal solution having opposite charges is called zeta potential or electrokinetic potential. I will repeat this. The potential difference between the fixed layer and the diffused layer of the colloidal solution having opposite charges is called zeta potential or the electrokinetic potential. Then last one is the Kraft temperature. Simply T subscript K. The Kraft temperature, the temperature above which missile formation takes place. The temperature above which missile formation takes place is called Kraft temperature. I will repeat this. The temperature above which missile formation takes place. This is the key point. Temperature above which missile formation takes place is called Kraft temperature. Look at the next question. Out of barium chloride and the potassium chloride, which one is more effective in causing coagulation of a negatively charged colloidal salt, and give reason, that is why. Here, which is the more coagulative species in BaCl2, barium chloride and the KCl. Here, the barium chloride, the answer is barium chloride will be more effective. The reason here, the reason is because of Ba2 plus ion. This is Ba2 plus ion have higher charge than the potassium plus ion. Here, the barium having this positive ion, that's mean this having the plus 2 charge and this having the plus 1 charge. So out of this, the barium chloride is more effective on causing the coagulation because of the high charge. In case of aluminum chloride is given, means aluminum chloride is the, which one is suppose out of this two, you have to look whether which compound is a higher positive charge. So this having the high charge compared to the KCl. In case AlCl3 is given, means that is Al, aluminum is the more effective on the causing of the coagulation. So this is the answer. Then the next question is, a delta is formed. Here a delta is formed at the melting point of sea water and the river water. You know that you can see in that meeting of the sea and the river water, that is a delta is formed. See, usually the river water, that is the muddy river water, is a colloidal solution which gets coagulated by the electrolytes present in the sea water. That is why the delta is formed, because the sea water contains more number of ions, sodium ion, potassium ion, chloride ion, so many ions are present. But in the sea water, most of clay, that is in muddy water, that is why they are reactive with the ion, they are coagulated, so that the delta is formed because of the coagulation, the presence of electrolyte in the sea water. So this is the key point. Then the physics-absorption is reversible, while in the chemistry-absorption is irreversible. Why? What is the reason? Physics-absorption is reversible and the chemistry-absorption is irreversible. Why? Here in the physics-absorption, look at the physics-absorption, the forces of attraction. Reason mainly, the forces of attractions are weak and no new substances is formed. So therefore they are reversible. I will repeat this. The physics-absorption is forces are weak, no new substances formed, that is why they are reversible. In the chemistry-absorption, forces are strong. This means whereas the chemistry-absorption new substances are formed, therefore they are irreversible. Simply you can tell that new substances are formed, that is why they are irreversible. Here the forces are weak, that is why they are reversible. Then the next question is, what is mean by the dialysis? What is mean by the dialysis? That is the process. See, the removing the dissolved substance from the colloidal solution by means of the diffusion through the suitable semi-permeable membrane or simply membrane. I repeat this. The process of removing dissolved substance from a colloidal solution by means of diffusion through semi-permeable membrane or suitable membrane. So, this is called dialysis. Then, define peptidization and salt. First, I will tell you that definition of the peptidization. The peptidization, the converting freshly prepared precipitate into the colloidal form. That is the presence of the stabilizing agent. So, peptidization means what? I will repeat this. A process of converting freshly prepared precipitate into colloidal solution in the presence of the stabilizing agent. So, this is called peptidization. Then, salt. The salt means simply solid is dispersed in liquid. The solid is dispersed in liquid. It is called salt. Simply they are called salt. Then, why ammonia gas absorbs more readily than nitrogen gas on the surface of the charcoal? The question is, why ammonia gas absorbs more readily than N2, nitrogen gas, on the surface of the charcoal? Here, the ammonia, look at this, the ammonia having more van der Waals forces of attraction than in nitrogen. So, as NH3 here, the ammonia is polar and can form hydrogen bond also. So, therefore, it can get absorbed more extent than nitrogen. The reason I will tell you this, repeat this, ammonia has more van der Waals forces of attraction than the nitrogen. So, here the NH3 is a polar, can form the hydrogen bond also. That is why they can get absorbed to more extent than nitrogen. So, this is the answer. Next question is, what is the role of activated charcoal in gas mask? Here, the activated charcoal absorbs poisonous gases but not oxygen. This is the main thing. The activated charcoal absorbs the poisonous gases but not oxygen. Therefore, it is used to save us from the harmful gases. So, I will tell you that answer again. What is the role of the activated charcoal in the gas mask? Here, the activated charcoal absorbs poisonous gas but not oxygen. Here, the key word is activated charcoal absorbs poisonous gas. Absorb poisonous gas is very important point. And but not oxygen. That is why they are used in the coal mines like this. That is in harmful gases. They are used to save us from the harmful gases. Then next is, a colloidal solution of this silver iodide is prepared by adding silver nitrate solution drop by drop to excess of potassium iodide solution. What will be charge on the salt so formed? So, what is the cause of this charges? Here, the silver iodide and the iodide ion. It will be the negatively charged colloid due to the adsorption of the iodide ion and the silver iodide. So, I will repeat this. A colloidal solution of silver iodide is prepared by adding of the silver nitrate solution drop by drop to excess of potassium iodide solution. What will be charge on the salt so formed? What is the cause of the solution? Then the answer is AgI and iodide minus ion. So, it will be negatively charged colloidal due to the adsorption of the iodide ion and the silver iodide. Then next is two gases A and B. The two gases A and B have the critical temperature of 430 Kelvin and 190 Kelvin respectively. which gas will be readily absorbed and why? That is the reason why this happened. Here gas A and the gas B. The gas A temperature is what here? 430 Kelvin. Gas B is 190 Kelvin. Here the A will be readily absorbed due to the more forces of attraction. That is why it has a high critical temperature. So here the A is a correct answer. A will be the readily absorbed due to the more forces of attraction. This is the key point, and it has the high critical temperature. The critical temperature is 430 Kelvin for A gas. That is why the A is readily absorbed. Okay. Then FeCl3. Here ferric chloride is preferred over KCl, potassium chloride, in case of a cut leading to bleeding. Give reason. Here the answer is Fe3 plus ion. Here the ion having plus 3 state. Fe3 plus ion has higher charge than the potassium ion. Here the potassium is plus 1 stage and this is plus 3 state, and this having the plus 1 state. So the higher charge is what? The potassium, ferric chloride having the higher charge, so that more effective in the coagulation. Usually the higher charge substances more effective in the coagulation of the blood. So also the ferric chloride is more appropriate for the skin than the potassium chloride, as in the iron present in the hemoglobin. That is why the ferric chloride is the preferred over the KCl solution in the case of cut leading to the bleeding. So this is the reason. Okay. Hi students. See, today we were seeing the physical chemistry part, that is surface chemistry, up to lesson 1 to 5, the physical chemistry part. The physical chemistry part, totally you have 23 marks. In this lesson, completely theoretical part. So just go through this lesson clearly, then you can get a good marks in this board examination.